Hey everyone, so in today's video we're going to go over some solution stoichiometry problems. So for the first problem here, what volume of a 0.4 mole per liter CaCl2 is required to completely react with 65 milliliters of 0.3 mole per liter Na2CO3? So before we start anything, we need to get into the habit of writing our balanced chemical equation, which in this case is going to be CaCl2 plus Na2CO3. And that is going to give us CaCO3 plus NaCl. And to balance this equation, we simply need to put a 2 in front of the NaCl. Now with that in mind, we can start with our calculations. For the first step here, we're going to take our 65 milliliters and we're going to convert it to liters, which is going to give us 0.065 liters. And we're going to use that and we're going to try to get the moles of Na2CO3 by using the concentration of Na2CO3. So we're going to multiply it by 0.30 moles per liter of Na2CO3. And when we do this, we can see that our liters are going to cancel and we're simply going to be left with moles of Na2CO3 on the top. And then from here, we're going to try and convert it. We're going to convert it to CaCl2 using a conversion factor from our equation. And when looking at the equation, CaCl2 and Na2CO3 both have 1 mole. So it's essentially like we're doing nothing, but we can still write it out. Now from here, the moles of Na2CO3 cancel and we're left with moles of CaCl2 on the top. And as our last step, we're simply going to divide by the concentration. Or we can write it as 0.40 moles with liters on top. And here, the moles are both going to cancel and we're going to be left with a volume. And when you plug this all into a calculator, you get 0.04875 liters. Let's try the next problem. 29 milliliters of 0.31 mole per liter Na3PO4 is completely reacts with 36 milliliters of AlNO3. What is the concentration of AlNO3? So once again here, our first step is going to be to write out the balanced chemical equation, which is going to be AlNO3 plus Na3PO4 is going to produce AlPO4 plus NaNO3. Now to balance this equation, we simply need to put a 3 in front of the NaNO3, or the sodium nitrate. Now that we have that, we can start with our calculations. We're once again going to start with our volume. We're going to try and calculate for moles of Na3PO4. So we're going to take our 29 milliliters and convert it to liters, which will give us 0.029 liters times our concentration for Na3PO4, which is 0.31 moles per liter of Na3PO4. So here we can see our liters are going to cancel and we're going to be left with moles of Na3PO4 on the top. And then we're once again going to use a conversion factor. We want to get AlNO3, but when we look at our chemical equation, we can see that AlNO3 and Na3PO4 both have 1 in front of them. So we can write 1 AlNO3 over 1 Na3PO4. And now our moles of Na3PO4 are going to cancel and we're going to be left with moles of AlNO3. Now from here, we want to get a concentration, so we're going to divide by liters and we're going to convert 36 milliliters to liters and then we're going to divide by it, so times 1 over 0.036 liters. And we're going to be left with moles on top and liters on the bottom, which is our concentration. And when you plug all this into a calculator, you get 0.2497 moles per liter, or 0.250 moles per liter. Let's try one last problem together. What mass of BaSO4 can be produced if 65 milliliters of 0.5 mole per liter BaCl2 solution reacts completely with excess Na2CO4? So once again, just like the other two, we need to write our balanced chemical equation. So it's going to be BaCl2 plus Na2SO4, and that is going to produce BaSO4 and NaCl. Now to balance this equation, we simply need to put a 2 in front of the NaCl. And now from here, we can start with our calculations. We're going to once again take our volume. We're going to convert 60 milliliters to liters, which is going to be 0.060 liters. And we're going to try to get our moles of BaCl2, so we're going to use our BaCl2 concentration, so times 0.50 moles per liter of BaCl2. So the liters are going to cancel, and we're going to be left with moles of BaCl2 on top. We're going to use the conversion factor again, and once again here the conversion factor is 1 to 1, since if you look at our chemical equation, there's 1 in front of the BaSO4 and there's 1 in front of the BaCl2. So we want BaSO4, so it's going to be on top, over 1 BaCl2. And now we have the moles of BaCl2 have canceled, and we have moles of BaSO4 on top. And now from here, since we want the mass, we're going to multiply by the molar mass of BaSO4, which is 233.39 grams per mole. And our final answer here is 7.00 grams of BaSO4. I hope this video helped. Thank you.